And welcome to SanfordFlipMath. We are, as you know, deep in the throes of PreCalculus. We are working through the Demana Waits Foley Kennedy PreCalculus book, 5th edition, or maybe 4th edition, depending on which copy you have. And we are working in section 2.8. We are wrapping up chapter 2, solving inequalities. And we are using sign charts to solve the inequalities. And we're using test points to kind of fill those values in. So we're just going to, this video is just basically 3 examples, and there are 2 types. One kind of example is where I ask you for specific intervals or chunks of values where the function is 0, undefined, positive or negative, or I may or may not ask about undefined depending on if there's a denominator or a square root. If the other option would be that, you know, this whole fraction or something like this may be less than 0 or less than or equal to 0 or something similar to that. Okay? All right, so the process is first find the boundaries. So remember, that's where things are equal or maybe undefined, or at least undefined over reals. In other words, we're not going to work with imaginary numbers for this particular kind of equation or inequality. So let's start by doing that. We're going to find the boundaries. So in this case, we're talking about where it's equal to 0 or where it's undefined. So equals 0. And again, a fraction is equal to 0 where its numerator is equal to 0. Or you could, you know, do what we did in section 2.7, and that's multiply both sides by whatever that denominator is. And when we do that, the denominator goes away, leaving just x plus 3, x minus 3 equals 0 times, who cares, is 0. Okay, sorry, that was x plus 1. Okay, thank you for those of you who just tried to tell me through the airwaves and time and space. Okay, so the values that make that true are x equals -1, x equals 3. Okay, now the other concern is, so those are the values that make it equal to 0. The other values where things, where we have domain issues or things that make it undefined, well, I can't have that square root of x plus 4 equals 0 because that makes the whole thing undefined. The whole fraction becomes undefined. Well, that happens when the inside of this is 0. And so that happens when x is -4. So this particular one, I'm actually going to have 3 boundaries this time. So those 2 and that one. Okay, so we're going to build a sign chart. Okay, and again, what we're putting on our sign chart are x and y values. And remember this, the boundaries must be in numerical order. -4 makes this undefined. -1 makes this 0. And I'm squeezing now. 3 also makes this 0. Okay, so this is going to be our sign chart. And then what we're going to be doing is building little mini versions of this equation. So I have some parentheses and a square root, and some parentheses and a square root, and some parentheses. That's not an x in the middle. Those are just the parentheses. And I need this for every little region on this graph. So we're going to do this 4 times. Okay. So, and now what we're going to do is take test points. So I'm going to switch colors here. We're going to take test points for each one of these regions. We're going to put them into this and actually see whether things come out positive or negative. So I need something to the left of -4. Okay, let me make some quick notes here. X is less than 4, -4, excuse me, between -4 and -1, and between -1 and 3, and to the right of 3. Okay, and as you already know, you could do this with intervals. Okay, and I probably shouldn't take the time to do this, but I'm going to do it anyway. Sorry. -1 to 3, and from 3 to the right. Okay? All right, so we're going to take some test points. For instance, for this leftmost region, I'm going to use x equals, I need something to the left of -4. How about -10? You can use -5, you can use -4.1, you can use whatever you want, just as long as it's less than -4. So -10 plus 1 is negative. -10 minus 3 is negative. And then -10 plus 4 is also negative. Now, I want to go ahead and deal with this right now. the square root of a negative is imaginary. And if I do a positive divided by imaginary, it ends up being imaginary. Okay. All right, moving on up. Okay, so that establishes what's going on there. Okay. All right, let's do between -1 and -4, let's do -3. Okay, and again, you can pick any value between those values. So -3 plus 1 is negative. -3 minus 3, also negative. -3 plus 4 is actually positive. So this becomes positive divided by, I can do the square root of a positive, that's also positive. So overall, this is positive. Okay. And then continuing on, between -1 and 3, you know I'm going to pick 0 because 0 is so easy to work with. 0 plus 1, 0 minus 3, and 0 plus 4. Okay, square root of a positive is positive. This is negative. Overall, this is negative. So just track what's going on with your sign rules. Positive times a negative is negative. Negative over a positive is negative. Okay, and then one more value that we're going to put in, something greater than 3. So, sorry, let's do maybe 5. Okay, so 5 plus 1 is positive. 5 minus 3, positive. 5 plus 4 is 9. Square root of 9, well, so that's positive. Square root of that positive, so everything here is positive, so there I am. Okay? All right, so let's start answering some questions. Excuse me. So the zeros, okay, well, anything that makes it 0. Okay, let's do a little highlighting to make this a little bit easier to follow. Okay, so this -1 makes it 0, 3 makes it 0. Okay, so you guessed it, those are my zeros, -1, 3. Okay, undefined. Well, I only see one of those. It's right here. So x equals -4. Okay. Okay, positive. Well, that's here. And here. Okay, so, well, sorry, I need to keep going with that. Highlighting. Okay, so the positive is from -4 to -1, or from 3 to infinity. Okay, and last one, I hope I got another color, and I do. Yes. And that's, I haven't used that one before, have I? Just all excited. All right, so negative from -1 to 3. Okay. Now, there is one more thing that I could have listed on here, so I'm just going to tack it on just for kicks and giggles, and that is any place where I get imaginary values, and those imaginary values would be to the left of -4, and I don't have another highlight color. I'm all sad. Sorry. Okay, so those imaginary values would be to the left of -4, I said. Yep, thank you. So -infinity to -4. Don't include the -4 because at -4 itself, we already said it was undefined. Okay, all right, so that's it for that example. Okay, now what I would like you to do is do this example yourself. Now here, just a quick note, it is not factored on the top yet. What I'd like you to do is try and factor the top yourself, and then I want you to try and do the whole problem yourself. Now, if you get stuck with something, then hit play and just play the part that you need help with, and then hit pause again and then try and continue on. Okay? There's going to be huge power in doing this. You can anticipate where I'm going, then you know that you know. Okay? All right, so you go ahead and pause now. Okay, now I'm going to keep going now, and again, we're going to find boundaries, so that's going to be where it's either equal or undefined first, and I'm going to do some factoring on the top. Okay, this is still less than or equal to 0, and I can factor the x squared minus 4. Now on the bottom, this doesn't factor. X squared plus 2 is just x squared plus 2. Now, the other thing that you're going to hopefully notice here is that x squared plus 2 is always going to be positive. so it's really not an issue. I'm going to include it in everything I do with the sign chart, but we'll just speed right through that little part. Okay. So in terms of what makes it equal 0, okay, because those are the boundaries, is where it's going to be equal and also where it's going to be undefined. Well, again, as I just said, anywhere it's undefined would be from this denominator equaling 0, and it's never going to equal 0. Okay, so I don't have to worry about that, but I do have to worry about the top. So at x equals 0, x equals -2, x equals +2, those are all going to be boundaries. So those are the values that are going to go on my sign chart to start with. Okay? All right, so 0, -2, and 2. Okay, now, if you haven't already, gone ahead of me, this is another good spot to stop. You build the sign chart from this yourself, okay, and then you can check it. All right, so here's the sign chart. So x and y. I have -2. Remember, these have to be in order from left to right, because otherwise the whole idea of the test point thing doesn't work. Okay, and just a reminder that as we test these values, I have 3 factors in the numerator, x, x plus 2, and x minus 2, and I have a denominator. Okay, so this is a mini version of the equation just to keep track of signs so that I don't have to do the whole equation. I don't really care what number I end up with for these little area values. All I care about is sign. Okay, and remember that these values are zeros. Okay, all right, so here we go. We're going to pick a value. Oh, let me make my little notations here. From -∞ to -2, that's a weird looking infinity. -2 to 0, 0 to 2, and 2 to infinity. Okay, so here we go. Pick a value left of -2, so maybe x equals -10. Okay, well, now I'm actually going to work with this factored form because it's easy. Okay, so here we go. I'm putting in -10. -10 here, that's going to make that negative. -10 there is going to make that negative. Okay, and -10 there is going to make that negative. And remember, we already said this thing is going to be positive every single time, so I'm just going to go ahead and fill that in. Because something squared plus 2 is always going to be a positive number, even if it was 0 squared plus 2. Okay? All right, and now we're going to pick a value between -2 and 0. Now I can't pick 0 because 0 is not between -2 and 0. So I think the obvious choice is x equals -1. So this is negative. X plus 2 is positive, because -1 plus 2 is positive. -1 minus 2 is negative. Overall, this is positive. Sorry, let me pop back over here. Negative times a negative times a negative is negative. Okay. Pick a value between 0 and 2. So the obvious choice would be 1. You can pick 1.8 if you want. I don't think it's very fun, but okay, so 1. 1 is positive. 1 plus 2 is positive. 1 minus 2 is negative. So overall, this has a single negative sign. It ends up being negative. Just doesn't seem fair, does it? Pick a value to the right of 2, something like 763. 763 is positive. This is all of these are going to be positive. You can plug them in. Okay, so now we need to write the solution. At this point, I have organized my information in a very, very convenient way. Now I need to go back to the original and see how this says less than or equal to. Well, I need a word that means less than 0, and that word is negative, or equal to 0. Okay, so what I'm going to do then is, now I'm going to highlight because I'm sweet like that. So negative, well, it's negative here, and it's negative here. And I also need equal to 0, so I need that here. Okay, so that's all of that. And I need equal to 0, and that's all of that. Not the parts that are positive, just that. Okay, so now I need to, based on that, I need to write down what those values were. Okay, so that was from -infinity to -2. Did not include the negative infinity, but it did include the 2. So use a bracket to show the or equal to. Or, well, I'm going from 0 to 2. It does include the 0. It does include the 2, so I include that. This is my solution. Now, I know some of you don't like that form, so you can certainly do this. And from 0 to 2. Now, please don't mix and match. If you're going to use the interval notation, use it. If you're going to use the inequality notation, use it. But please don't mix and match in the same problem. Now, I'm fine if this is number 7 and you do this with interval notation, and then number 8 you decide, you know what, I'd rather use the inequalities. That's fine. But please don't do half interval notation and half inequalities. That's cheesy. Okay? All right. Well, I was going to do one more example, and I think what I'm going to do is I'm going to kind of do parts of it, pause, and do another part and pause, just so you can, I'm going to keep the video length down, but I want you to see another example. Okay? All right. Okay, those boundaries came from what will make those two factors equal to 0. And this is the sign chart setup. Okay, so you know, all of the different regions between -3 and 1 and around them. Okay, a quick little note here. These are the little versions of the mini equation. And I'm really not going to bother with putting signs in these absolute values. I'm just going to remind you that they have to come out positive because of the absolute value. Okay, so really I'm not showing the sign that's going inside of them. I'm just saying, look, that part's going to be positive. Okay, and those are the values for each of those sets of signs. So negative times a positive times a positive, and a positive times a positive. Okay, now this particular one wants it to be greater than or equal to 0, which means positive or 0. So I'm looking at the y values now to decide exactly what things I'm going to keep. Well, I want positive, and I also want the 0 part, okay, because I want positive or equal to 0. Okay, and now I just need to write the solution. Well, it looks like we're including everything from here over. Okay, so this is actually pretty easy to write. I'm just going to say from -3 to infinity, and I'm including all of that. And again, if you'd prefer, you can write it like this. Okay, and just a little bit of highlighting to make everything look nice and spiffy. Okay, and my OCD folks, or CDO for the truly OCD, because it needs to be alphabetical. And we're good. All right, well, thanks for watching, and if you have any questions about this, we will talk in class. Okay, see you then. Bye.